Hello, welcome to this tutorial on image operations. Before we can start, we need to load an image. So we'll go to the File menu, we'll select Open Image, and I'll select the file Blob. Press the Open button, and we're now given the question mark cursor, and what this is saying is where do we want to store the image. So we'll say we'll put this into image buffer A. I've already created an image operations toolbox, but for the purpose of this demonstration we're going to use the operations menu item. And we'll start by looking at constant operations, and in this we've got the option of adding, subtracting, multiplying and dividing each pixel in the image with constant data. So if we say add, for example, we get prompted to enter a new constant that we wish to add to every pixel in the image. For argument's sake, I will add 50 to every pixel in the image. We're now presented with the question mark cursor, which is saying select the image, and this can either be the image window or it can be the toolbox, the tool button. So I'll select the image window, and we want to put the destination into image buffer B. So what we can now see is we've got the two images and the intensity has been shifted up by an intensity count of 50 in the second image. I'll now delete image buffer B, which I do by double right clicking on the button B, and we'll now have a look at another operation. So we'll go to Operations, Constants, Subtract. Now this time I'm going to subtract 50 counts or 50 intensity values from every pixel in the image. Again, pressing OK. Again, we're prompted to select the source image, and I'll do this by selecting the window, and the destination image, which will be image buffer B. And I'll just move those side by side, and we can now see that the intensity value has shifted down by 50 counts. Multiplying and dividing work in a similar fashion. So we'll say operation constants multiply. Now this time I'm going to multiply an image by 5. And what I'm going to show you here is the difference between how we handle 8-bit images and how we handle 16-bit images. So we'll now press OK, and again we'll select the sourced image of image A. Destination, in this case I will go to image C. And what we can now see is that the image itself has become totally saturated. This is because we've only got 8 bits worth of data. We can tell it's only got 8 bits of data by looking in the lower bottom right hand corner. We see that there isn't any display translation associated with 16 and 32-bit images. Once we've done this, anything that is above intensity value 255 is clipped to 255. We can see this as we move the cursor around the image. The intensity value is showing as 255, and this has destroyed the data in the image. So if you're using multiply or any function which is likely to saturate the image, you will lose data. Now, to overcome this problem, we can operate in 16-bit image mode. And before we do that, we would need to copy an image to 16 bits. So we'd say Operations, Copy to 16 bits. And I'm going to select image buffer A, and we'll put the result back into image buffer A. So I'll select image buffer A a second time. Now, on the face of it, the image looks exactly the same. But what we can see now is that the bottom right hand corner of the image shows the display translation of bits 0 to 7, which means that it's showing the least significant bits of a 16-bit image. If I now do the multiply function again, and we say multiply by 5, OK, and we'll select image buffer A as the source, and this time I'll put the result into image buffer D. And I'll just move those images side by side. And again, we get a very similar effect between the 8-bit image on the left-hand side and the 16-bit image on the right-hand side. The difference is that all of the information is present in the 16-bit image. And if we now go to the display translation, we can scroll through the bits doing a bit shift, which brings back all of the data that we originally had. And just to give you an indication, if we go to this part of the image here, in the bottom left-hand corner of the image window, that's down at the bottom here, we've got the intensity value. So at this position here, we've got a value of 136, 138, 140. If we now move to the 16-bit image, we can now see in the same area, the intensity value, we're looking at 600, 700, 690. So that's holding and storing the real data associated with the image, and this is an important thing to remember. Carrying on with the operation menu and the constants, the divide function works in a very similar fashion to multiply. We've also got logical functions and, or, and exclusive or, and these are fairly specialised, and the majority of users won't need these functions. A couple of other functions that may be of use are the ability to clip images, and we can either clip the low value or clip the high value. So if we say clip low, again we're prompted to set a value, and I'll set a value of 100. And what this is going to do is to prompt us to select the source image, and I'll point to image buffer A, and put it into a destination image buffer B. And what this has done is to take any value that is less than 100, and I'll just zoom in on the image, and we can now move the cursor, and it's now set that to 100. So anything that was less than 100 is set to 100. Okay, so we'll now have a look at some image operations. But before we can process images, we have to have two images which are of the same XY size and same depth. So what I'm going to do is to create a new one, which is in fact a flipped image of image A. So I'm going to take image A and I'm going to flip it to create image B. So if we now go back to the image operations, we can add two images together. And I'm going to say I want to take image A and add it to image B and put the result in image C. So from this we can now see that the two intensities have been added together to create the third image. Similarly, we could say subtract from image C, we will subtract image B and we'll put the result into image D, which should leave us with what we had in image A in the first place. I've got a bit of working space, get rid of D and we'll get rid of image C. Again, operations, we can multiply and divide images in the same way. I won't go through those now. Carrying on with the image operations, for us to work with logical functions, and this is things like and, or, exclusive or, and not, we need to create a binary mask image. And the way that we do this is to go to Image Enhancements and select Threshold. And what this is going to do is ask us for a source image, which again can be the image in the window A, and a destination, which we'll put into image buffer B. And we're then given a slider, and we can adjust this slider to set a particular threshold in the image. And I'll now press OK. And what the logical functions allow us to do is to work between the image and the mask. So if I now say image operations and, what this is going to do is to say where there is data in image A and there is a logical 1 in image B, that's where there is white area, we will get data in our resulting image. So I'm now going to put the result, it's asking us to select a source image and the image to and, which is image buffer B, and we'll put the result into image buffer C. So what we can now see is that the resulting image, where we have got white, we've got the data in image A, and where we've got black, it's black, no counts at all, or no intensity values at all. we can also invert the thresholded image. So if we go to Operations, Image Operations and Not, and we select Image Buffer B and we put the result into Image Buffer C, we've now inverted the mask. So if I now do a logical AND function again, and we select the source image of Image Buffer A and the logical mask image and the destination of Image Buffer D, what we can now see in the new window is anything that is black and anything that is white is the original data. We'll now have a look at some of the enhancement functions. We'll start with smooth. What we're asked to do is to define the size of the smoothing matrix, which is a default of 3 by 3 pixels. However, for the purpose of this demonstration, we'll make it a bit more aggressive, so we'll set it to 7. If I press OK, again we're asked to select the source image and a destination image buffer, which we'll put into Image Buffer B. And what you can see now is that the image has been significantly smoothed, and the larger the number, the more aggressive the smoothing. Similarly, we can sharpen an image. So we go to Sharpen, and again I'll make this fairly aggressive. We'll select 7 again, and we'll select Image Buffer A, put the result into Image Buffer C. And what this has done is to make the edges slightly more sharper. But what you'll also notice is that the random noise in the image has been significantly reduced in the smoothing and accentuated in the sharpening. Just get rid of a couple of images. If we go back to Operations again and Enhancements, we've already had a look at the threshold option. Contrast stretching and contrast flattening are probably things that you won't use very much. Erode and Dilate are probably worth a quick look at. What Erode is going to do is to take the source image, and again I'll do this fairly aggressively, so I'll select a number of 7. We'll select OK, and we'll select Image Buffer A into Image Buffer B. And what this has done is to make the black areas of the image blacker. If we go to Operations and we select Dilate, and again we use a similar filter of 7, and we select source image A into buffer C, what this is going to do is the opposite, and it's made the white areas bigger. So erode makes the dark areas bigger, and dilate makes the white areas bigger. And this can be sometimes useful if you're wanting to define areas for automatic mask detection. Also in the Image Operations Enhancements menu are the possibility of carrying out some various filter operations, and we've got 4 filters as predefined. There's a Laplace transformation, which I'll go from image A to image B. If I then do the Roberts transformation from image A to image C, the Sabel transformation from image A to image D, and then finally the Canny filter from image A to image. And what this is now going to do is to actually prompt us to select a threshold, and it will find the edges of the data in the image. I'll just put those side by side so that we can get a better idea as to what the results of all of them look like. We'll now have a look at the orientation functions. Flipping an image from image A into image B has basically taken the top of the image and put it to the bottom, and the bottom to the top. Operations mirror, if we go A to C, and what this has done is to flip the image left to right. and then we've got the options of rotating an image through 90 degrees, so we'll go A to D. Similarly, and I won't go through all of these options, we can rotate by 90, 180 and 270 degrees. We can also rotate an image by an angle defined by a line that we draw on the image. So if I go to Operation, Orientation, Rotate, select Image Buffer A as the source and Image Buffer B as the destination, we're then requested to draw a line on the image. And what I'm going to do is to start at the left hand side and draw a line to the right. If it's below the horizontal, it will rotate by a positive number of degrees. So I guess at the moment we've got an angle of about 10 degrees when I let go of this. Well, it's told us in the top of the image that it's rotated by 7 degrees. Probably more useful than rotate is the orientation align function. Now, if we select the source image as image A and the destination image as, in this case, image C, and we draw a line, and we draw the line going from left to right, what this will do is to rotate the image so that that line becomes close to horizontal. If on the other hand we do the same function, and we'll go to align again, and I'll go image buffer A to image buffer D, and instead of going left to right, I go right to left, what it will now try and do is to rotate the image such that that line is close to vertical. We'll now have a look at the enlarge function. So we'll go to Operation, Enlarge. Now, when we enlarge an image, we can do one of two things. We can enlarge it so that the intensity values in each pixel remain the same, or we can enlarge it such that the total number of counts in the image remain the same. But because the size of the image has gone up, we will reduce the number or the intensity count in each pixel. So first of all, we'll do it with a factor of 2 by 2, and we won't reduce the intensity. So we're selecting image buffer A as the source and image buffer B as the destination. And what that's done is to make the image twice the size in X and twice the size in Y. If on the other hand we do the same function, but this time we select reduce intensity, and we go from image buffer A to image buffer C, what you can now see is that the intensity in image buffer C is much lower than that of image buffer A. But if this were a photon counted image, the total number of photons detected in image buffer A would be the same as the number of photons in image buffer C. Like enlarge, we can also reduce an image in size. So I'm going to reduce this image by a factor of 2 in X and a factor of 2 in Y. Now, when we reduce the image, we can either decide to make the new pixel the sum of the 4 pixels in this case, this is the 2 by 2 matrix, or the minimum of any of those 4 pixels, or the maximum of the 4 pixels, or the mean or average of the 4 pixels. So I'll say, to start with, mean. And we'll go from image buffer A to image buffer B. So what we can now see is that the two images just reduced in size. Now, in order for us to sum the images, we will need to make sure that the image is a 16-bit image. So I'm just going to copy this to a 16-bit image. Oops, sorry, let's do that again. Operations, copy to 16 bits. And what we'll now do is reduce, but this time we will put the method as the summation. So we'll go image buffer A to image buffer C. And what you can now see is that the pixels have been saturated, but I can use the display translation bits to shift the image by 2 bits. Now effectively the intensity value in this image is 4 times the intensity value in the original images. We'll now have a look at the ability to join images together. So I'm going to select Join Horizontal, and I've got 2 images, one in image buffer A, the other in image buffer B, and we can join these 2 images together. So I'll select image buffer A and the image in buffer B, and we'll put the result into image buffer C. So that's now joined those 2 images together to form a single image. We can also, if we want to, join them in the vertical format. So again we'll say join, but this time vertical, and again image A to image B to image D. Just like joining, we can also split images. So we can go split, and we'll split a vertical 50% image, and we'll select image buffer A as the source, and then we've got to select 2 destinations. Destination for the first part of the split and destination C for the second part of the split. So we can see now we've now got back the original 2 images that we had. If you want to, you can also split them at a different position. So I'll select vertical select, and again we're going to go image buffer A, and we'll put them into E and F, and we now get presented with a line which is the split point. I've now loaded a sequence of images, and what we'll do to start with is to split a number of these sequences out into individual frames. So we can say sequence, separate frames from A into image buffer, or images starting at buffer C. And what this has done is to create a number of different images from the sequence file. And what I want to do is to show you the ability to join images using the matrix command. And we've got 2 options here. One option is to use images, and we'll start by doing this. Go to the image, and we're prompted to select a group of images. When we select a group, we select the first image and the last image. What this will do is it will detect how many images there are and try and decide a matrix that is appropriate to that. And it's taken a best guess at 5 rows by 5 columns for the 24 images. But if you wanted to, you could have 6 by 4 or any other format that is available in the drop-down list. And it will automatically try and fit that to an image. And the new image size is going to be quite a large image. The alternative is that we can make the image a fixed size, either making it larger, multiplying it up, or dividing it down by a factor of 2, 4 or an 8. We can arrange for the images to go left to right or top to bottom within the matrix. So if we select horizontal, we'll just press the preview button. We can now see the images going from left to right. If I select vertical and do preview, it's now gone from top to bottom. And we can also put an outline around each of the images if we wish to. And we can press OK, and we'll put that result into image buffer B. And if you press the right hand mouse button, that will then fit the image to the window. We can also generate a matrix directly from a sequence image. So if we go to Operations, Matrix and select Sequence, if we select the sequence image buffer, in this case image buffer A, it will again automatically try and find the appropriate matrix to fit in the 70 selected frames. And we'll press preview, and this gives us an indication as to what the image will look like. If we're happy with that, we can then press OK. If we want to change the orientation to a horizontal orientation, press preview again. When we're ready, we press OK, and then we have to select the destination image buffer where we want to save the image. In this case, we'll save it into image buffer B. and again if you move the cursor into the image and right click, it will fit the image to the window. This concludes the tutorial on the image operations menu. I'm sorry it's taken a little long, but I hope you find it useful.